Hello everyone. This question has been taken from Olympiad Pathfinder MCQ multiple choice question number 27 belonging to chapter 2. Section is Newton's law of motion. Question goes like a homogeneous bar of mass m is released from rest on a fixed inclined plane of inclination theta above the horizontal as shown. The upper part of the plane shown in dark gray is not frictionless. So this part is not frictionless. And the lower part shown in light gray is frictionless. So from here it is frictionless. So coefficient of friction between the bar and the upper part of the plane is given as mu. The coefficient of friction for this surface and the bar is given as mu. What will be the maximum tensile force in the bar while it is sliding on the plane? Acceleration of free fall is g. 4 options are given and we have to calculate and see which options are correct. So let us discuss this question and situation. Initially, what is happening when the entire bar was on the friction surface and bar being homogeneous, so each and every point of the bar will be experiencing a friction force opposite to its motion in equal magnitude. Okay. So in this situation, the tension in the bar will not be that much when compared to the situation when the part of the bar is in the frictionless area and part of the bar is in friction area. So what will happen in this case? The part of the bar which is in the frictionless area will be accelerating, will have the higher acceleration if it was independent. If it was independent or cut off from this section which is on the friction surface. But since entire bar is an integral part, so what will happen? So this part will try to move faster, whereas due to friction force acting on this portion will move slower. So this situation will arise. So when this situation arises, so this portion of the bar will try to pull this section of the bar. Okay, this section of the bar which is on the friction surface faster towards itself, and whereas this being slower, so this will try to pull the section of the bar which is on the frictionless surface in this direction. So because of this, the tensile force will increase. Okay. Now, in the question, it is asking in what condition the tensile force in the bar will be maximum. So we have assumed that when the part of the bar, x length part of the bar was on the frictionless surface and L minus x length was on the friction surface, the tensile force is maximum. Okay. Acceleration, we have assumed that the entire bar is, because it is an integral part, so it will move, it is moving down with an acceleration a along the inclined plane. We have taken x-axis parallel to the inclined plane and y-axis perpendicular to the inclined plane. Okay. To study the forces, we will make the free body diagram of this portion. Is the bar which is on the frictionless surface and having a length of x. Okay, so this is the diagram which has been shown here. So which all forces are acting over here? Since it is of x length, so lambda into x will be its mass. So lambda into x into g will be the gravitational pull on this section of bar, right? Component of this will be along the inclined plane is lambda into x into g sine theta, as you was writing as mg sine theta. But since here so we have taken as the linear density as lambda and x is the length, so lambda into x is the mass into g sine theta, okay? And assume that T is the tension force which is acting over here, okay? And A is the acceleration. So we will apply Newton's law of motion and write an equation for this. The summation of force in the x direction is equal to mass, lambda into x is the mass, into acceleration, okay? So we will write down all the forces acting in the x direction. So lambda into x g sine theta is acting in this direction of x, and t is acting in this direction. So it is in opposite direction of the lambda x g sine theta. So lambda x g sine theta minus t is equal to lambda into x into a, because we are trying to write the equation towards which the acceleration is shown, towards which the bar is sliding down with an acceleration a, okay? Similarly, we will write an equation for L minus x section of the bar which is on the frictional surface, which is on the friction surface. So this is the bar, which all forces acting over here. Friction force we knew that it is mu into n, the normal reaction. Normal reaction, okay, from Newton's third law, tensile force in this direction acting on x section, so L minus x section, it will be acting in this direction, right? So this is the tensile force, and weight of it is lambda into L minus x into g, fine. The component of this lambda into L minus x into g along the inclined plane is lambda into L minus x into g sine theta. Since this one is moving with a acceleration, this will also be moving with an a acceleration, because this is a rigid configuration and all the parts will be moving together unless or until it is break. Okay. Now in y direction there is no motion, so n will be equal to your lambda into L minus x into g cos theta. So this, you know. Okay, so we have taken all summation of fy 0, so n is equal to this, number 2 equation. Summation of fx, all the forces in the x direction, so lambda into L minus x into a from the Newton's law of motion, and we have put all the value, okay, and we got this equation, number 3 equation, okay. So putting the value of n from equation 2 in 3 and dividing the result by equation 1, okay, so what we got is this equation. It's a simple equation, you can do by yourself. Okay, so first put n is equal to lambda L minus x into g cos theta in here and divide it by equation 1. The reason for dividing it by equation 1 is so that you don't have to worry about a part. A will cancel out, right? And when we solve it, the tensile force will come like this. T is equal to mu into lambda into Lx minus x square into g cos theta divided by L. So tensile force is coming as a function of x, right? And you know from the mathematics that for maxima and minima, you need to differentiate t with respect to x and equate it to 0. So this is what has been done here. Okay, and from here we got x is equal to L by 2. Okay, so this x, what we are getting, L is this x is equal to L by 2. What we are getting is the value at which the tensile force will be maximum. So in equation 4, when we keep the x value as L by 2, the tensile force will be maximum. So this is what is written here, T max. Okay, so you can put the value and you can, so when you calculate, you will get it as 0.25 mu into m into g cos theta, and compare with the options which is given. So option B. So option B is correct. So hope you understood the solving of this problem at each and every stage. If you feel any doubt or any problem at any stage, you can write in comment box. I will come back with reply. Thank you.